Previously on Just Add Science, we were talking about mass, and we were talking about this big giant rock and this little small rock, and how one was easy to move and one was not easy to move. If we took the small rock, and we could easily roll it down the hill, and that would be very easy for us to do, because the small rock, does not have a lot of mass. So moving it from the top of the hill to the bottom would be easy, and stopping that rock would be very easy. Then we moved on and we talked about a big giant boulder that was going to flatten Reagan. And getting that giant boulder would probably take all of us to push it over the top of the hill. But once it started rolling, it would be very hard to stop. And just knowing that the small boulder or the small rock is easy to roll and the large boulder is hard to roll, the small rock is easy to stop, the large one is hard to stop, leads us into this next topic. And the topic is inertia. According to our vocabulary sheet, inertia is the tendency of an object to stay at rest unless acted on by a force, and the tendency of that same object to stay in motion unless acted on by a force. Now, on the surface, that seems like an extremely technical and very difficult thing to understand. Mr. Bullens, in one sentence, in one breath, you're saying the object likes to stay still. In the other breath, you're saying the object likes to stay in motion. Yes, I am. Let's think about that a little bit differently. Let's imagine we had a bowling ball sitting outside in the grass where we have recess. If I set the bowling ball there, I would expect that bowling ball to be there the next time that I came out to look at it. The bowling ball would continue to sit there and it would stay in that same spot. And the bowling ball would be very happy to just sit there at rest. An object at rest stays at rest unless it's acted on by a force. That's inertia. So the inertia of that bowling ball is very happy to be sitting there. That's part of inertia. It's happy to not move unless it's acted on by a force. So over walks Aiden. Aiden picks up the ball and he starts to roll it. As he rolls the bowling ball says, "Hey, I kind of like this too. I enjoy being in motion, and I would prefer to stay in motion unless a force acts on the bowling ball." Now, we all know that if we picked up that bowling ball and rolled it, it would be happy to keep rolling, but it would not continue to roll. And the inertia says that the object in motion stays in motion unless acted on by a force. We ask ourselves at the bottom here, what force or forces are acting on the bowling ball that it's rolling in the grass to slow it down? We've talked about that. Hopefully you know the answer to that, and we'll go over that more as we go over this slide in class. But something slows that bowling ball down. So again, we're looking at inertia. An object in motion stays in motion, and an object at rest stays at rest unless they are acted on by a force. Here's the really cool part about this. If you get inertia and you understand it, you already understand another one of our vocabulary words, and that is Newton's first law. Because Newton's first law literally is him discovering inertia. The definition of inertia, the tendency of an object to stay in motion or to stay still. Newton's first law, an object at rest will stay at rest, and an object in motion will stay in motion unless acted on by a force. Newton's first law is pretty much him discovering that objects had inertia. And I think that we all pretty much understood that objects had inertia beforehand. We're not going to be surprised if a giant boulder is still sitting there the next time we go to look at it unless something acted on that boulder to move it out of the way. All right. This image, it was on the other background too, and on this background, that image in the background is something called a Newton's cradle. Yes, Isaac Newton. I really do need to get one of these for the class. I mean, I put that even in the notes too. I do need to get one. I think we had one and somebody twisted all the wires up, which is the big issue with Newton's cradles. It has a set of 5, sometimes more. Most of the times I usually see them like 5 balls attached to strings. Now they're just sitting there and they're very happy to be at rest. and they will stay that way. They're not going to start moving on their own unless a force acts on them. Inertia, an object at rest stays at rest unless a force acts on it. Once you pull back and let one ball go, they start bouncing back and forth into each other, and it sends one ball from the right side, it hits the balls, and it pushes the ball, all the energy goes through the other balls, and it knocks the ball on the left side all the way through. And they keep bouncing back and forth unless a force, friction, and some other things in this case, start to slow them down. They will not go on forever, although you think it will. It does not go on forever. And again, we have inertia. All right, another bell for school. So after this, I attached some videos. One is a normal size Newton's Cradle, and one is a very, very massive one. So you take a look at those two. And then I think there's some very interesting questions to be asked about this. And maybe we can have a discussion about this in class. Maybe we can have some sort of like a small assignment or something to go along with this as well. The small one works fantastic. They're really fun. The large one that they built on Mythbusters, blah, my tongue was tied there, works, but not great. And it's nowhere near what you see with the miniature one. I have my theories as to why it doesn't work. They mention some things in Mythbusters as to why they think it doesn't work. But I really would love to hear your thoughts on that as we move through the week and see if you maybe have a little bit better understanding about some of these terms that we've used, like force and inertia and friction and mass, and see if we can kind of piece those things together to figure out why the large one just doesn't seem to work that well. I just want to kind of go through this so you can see what I'm seeing and I'll understand what you're seeing as we go through the rest of this, because there's not much more that I can do as far as in this video. Here's your video of the small Newton's Cradle. Here's the video of the largest one. This is a fantastic article / videos on Wonderopolis about inertia. I think it would be very wise of you to read through that. You'll get some great information. We start here with Newton's laws. And you're going to notice that I don't really have any slides with definitions and vocabulary words and that kind of thing, because I have a completely different Nearpod deck that's all about Newton's 3 laws. But all of these videos, you can access them here, are in Discovery Education. They're all about Newton's laws, and they'll kind of give you that introduction. I'll probably do this in class to see if some people can give me some good feedback on that. And we'll do this in class, and obviously I think I'm definitely going to do this one in class because it's a collaborative board. It'll allow me to let people sign in, and I'll be able to see what their thoughts are, and it'll also help me. Do I need to go back and reteach any of this because people don't understand it? Because I don't want to move too fast, and I certainly don't want to move too slow, because as we talked with Mr. Reynolds and Miss Davis and Miss Morales this morning, quarter 2 is wonky. It's not going to be nearly as long as quarter 1. I mean, we're going to basically sneeze, and we're handing out, well, you'll be looking at your progress reports online, and then we sneeze again, and it's right before Christmas break, and we're handing out report cards. That's going to go fast, and we have a lot of stuff to cover between that time in all of our classes. And so we'll go through that together, and then, I must have attached that twice. I must have really thought this was important. You don't have to watch it 2 times. Don't watch it twice, because it's the same video the second time as it is the first time. I might have to go back in and delete that if I can. But as you can see, there's not a lot of stuff after the inertia slides that really dig into a lot of the vocabulary words. It's more videos for you to watch that give you background information, so when you do come into class and we're watching those and talking about those, you have a little bit better of an understanding of what's going on. And again, if you're here, we're going to watch them in class. If you're a remote kid at home on that certain day, you need to watch the videos at home, because I'm going to be covering them in class, and I don't want you to miss out on some of that important information. All right, well, that is inertia. I hope that made sense. Well, what did I just do? I think I just cut on a video. I hope that makes sense for everybody. Again, if you have questions or if you have concerns about anything, please have your parents dojo me, or you obviously you can email me. You can send me questions in Google Classroom, because those only come to me. Nobody else sees those. And I hope that helps you out with all of that. Anyway, don't forget to smash the like button and subscribe. And I'm looking forward to seeing everybody in class here pretty soon.